In this video, we're going to be simplifying a rational expression, and again, we're dividing. So notice not only do we have division going on here, but we actually are dividing a whole another term over here. So let's go ahead real quick and let's work through this. And just remember, when you approach these types of problems, the first thing that you want to do is you want to factor the quadratics. So don't do anything else until you've completed that. Now we have a lot to factor here, right? We're going to have to factor the first one, the second one, and this bottom one. So I'm going to go ahead and start with this one right here. So I have x squared plus 3x plus 2. I am going to go ahead and make my number tree, and I'm going to take my value of c, which happens to be 2, and its factors. Now the factors are 1 and 2. Notice that both of these are positive, so I know that it has to be positive and positive. So I didn't have to go through the process on this one because it was a little bit of an easier one to factor, of eliminating the combinations that it could possibly be. So when I write this out, I'm going to go ahead and write it out as x plus 1 and x plus 2. And that's because 1 times 2 gives me positive 2, and 1 plus 2 gives me positive 3. So those are my factors. So as we're going through this, I'm going to go ahead and start writing the problem again, but with the factors instead of the actual quadratic in standard form. So for instance, this top one right here, I'm going to write it down right here. We got x plus 1 and x plus 2. Now over here I'm going to put my division symbol, and on top, notice this one we didn't have to factor, right, because it's just a binomial and we're just going to write it out. So I'm just going to write it in here, x minus 3. Now I'm going to go ahead and we're going to start factoring out the denominators. So I'm going to do this one first, x squared minus 9. And so for that one, I'll just kind of make some space over here. X squared minus 9. I want to think about what two numbers can multiply to give me 9. And it's going to be 3 times 3 gives me 9. And remember that whenever you have one like this with no middle term, one value has to be negative and one has to be positive. If it seems confusing what I'm doing right here, go back and look at my video called Quadratics, Factoring the Difference of Two Squares. And it'll go over several problems and show you how I come up with this. So my first factor is going to be x minus 3, and the next one is x plus 3. So these are actually really easy to factor. Again, watch the video if you're not certain. So I'm going to go ahead and I'm going to write those factors down now. So those factors are going to go down at the bottom in the denominator. So I'm going to do x minus 3 and x plus 3. Now we still have one left to factor, and that's going to be this bottom one right here. So I'm going to factor this one next. So let me draw a line, creating some space, and I'm going to put in x squared plus 5x plus 6. So I'm going to go ahead and create my number tree, and remember we're looking for the factors of 6. So it's going to be 1 and 6 and 2 and 3. Now we got to make a 5, and notice we can make a 5 out of both of these. 6 minus 1 can give me 5, and 2 plus 3 can give me 5. So we want to go ahead and eliminate some possibilities. Notice that the 6 has to be positive when we multiply, and the 5 has to be positive when we combine. Well, that would mean that both of these, right, out of our combinations, which could be plus plus, plus minus, minus plus, or minus minus. If you looked at my other video, right? In other words, we're assigning these to each one of these terms. And if I were to make this a positive 1 and a positive 6, so to multiply to give me positive 6, the problem I run into is when I combine them and add them together, it would give me 7. And I don't need 7, I need a 5. So it can't be the 1 and 6. I'm going to make both of these positive. And 2 times 3 gives me 6. And 2 plus 3 gives me 5. So those are my factors. Now I'm going to write those factors out. We end up having x plus 2 and x plus 3. So now I'm going to take these factors and I'm going to write them in my denominator in place of that denominator. So x plus 2 and x plus 3. So now we are finally ready to go ahead and start eliminating some possibilities. So we're going to go to our second step. So step 1 was to factor anything that needed to be factored. And step 2 is to divide and cancel like binomials. Alright, that's kind of how I look at it. So let's take a look at what we have. Now, before you start canceling things out by looking at it right here, what you got to remember is this word divide. We must divide, right? This right here expression is getting divided by this expression. And remember that back in the day when you were earlier in school, maybe in elementary, you learned that whenever you divide by a fraction, you simply multiply by what we call the reciprocal. And I'm just going to show you an example of what I mean without all these letters, right? Because it may look confusing to you. In other words, if let's say you had 3 over 4 divided by 5 over 7, right? And what your teacher would tell you is if you're going to go ahead and you're going to divide this fraction by this fraction, they would tell you that you're going to multiply by the reciprocal. In other words, you would take the 7 and move it up to the numerator, and you would take the 5 and move it down to the denominator, and this would become 7 over 5. And then you'd multiply it, and 3 times 7 gives you 21, and 4 times 5 gives you 20, and then this would be your answer. So this is right here, right? When we flip these two numbers, the numerator and the denominator, so that we can complete that process of division, we call that the reciprocal. So we're going to do the same thing here. We have to create the reciprocal of this particular expression that's being divided by this initial one. So I'm going to rewrite this, and you'll see what I mean about switching it. So I'm going to rewrite this as x plus 2 times x plus 3 over x minus 3. And this is simply being multiplied to x minus 3 and x plus 3 and x plus 1 and x plus 2. Now, you can leave it like this and start canceling stuff out, but I want you to know that anytime we have a multiplication sign, it's basically just the same as you having a parenthesis, right? It just means you're multiplying. And I know some students that I've seen get kind of confused when we got this dot in between. So if you prefer, I'm going to rewrite this a little bit differently as a single line. If you prefer, you could write this simply as x plus 1 times x plus 2. And then I'm going to write the other numerator, x plus 2 and x plus 3. So if it helps you to just leave that dot out and just write it all beside each other, that's perfectly fine to do so, as long as you have all your terms written, because they really are just all being multiplied, and the order in which you multiply does not matter. And then I'm going to go ahead and write my bottom terms, x minus 3, x plus 3, and then we have this x minus 3 right here. Okay, so we have everything written out, and what we want to do is we want to go ahead and do the division now, right? Let's see what we can cancel out. So for example, I noticed that I have an x minus 3 here, and if I look on top, there are no x minus 3 binomials. So there's nothing I'm going to be able to do about the x minus 3. So I go to the next one, x plus 3. So I look up on top, and we do have an x plus 3 right here. So I'm going to cancel that one, and I'm going to cancel this one, right? So they cancel each other out. They can be divided out into 1, and 1 times anything is just itself. So it eliminates it. I'm going to look and see, is there another I can get rid of? I have this x minus 3 here. And notice when I'm looking across it, there are no other x minus 3's in the numerator. So again, I cannot cancel that out. So now we're going to go ahead and we're going to start to write our final answer. What we have left is x plus 1 times x plus 2 about this other x plus 2. Now the restrictions we have, right, are for the one that canceled. That one that canceled, we need to go ahead and set it equal to 0 and solve it so that we can have that restriction. So now that we're here, we're going to see if we can write this in a more simplified format. So first of all, I'm going to go ahead and box it, these two right here on top. Notice we have x plus 2, right? Two binomials that are being multiplied together, and they're the same. So when I rewrite this to kind of simplify it, make it easier, I'm going to go ahead and just write x plus 2 one time, and I'm going to put squared, right? Because that's what that means. There's two of these being multiplied. And then the x plus 1, we only have one term like that. So then I'll just write x plus 1. And on the bottom, I'm going to box these, because notice we have the same binomials being multiplied. And I'm going to write that as x minus 3 squared. Now again, we do have that restriction, so I'm going to put comma, x cannot be equal to, and the one that we had canceled out was x plus 3. So if I take that up here, running out of space, but here we go. So I'm going to do x plus 3 equals 0. And if I were to solve this, I would have x equals negative 3. So because of this, that is a restriction. X can never be negative 3, because it would create a 0 in the denominator. So I'm going to go ahead and put x is not equal, cannot be equal to negative 3. And that's the only restriction on this one, because we just had one set of binomials get canceled. And then this is my final answer.